Space represents very challenging extreme environment due to radiation, microgravity, and communication latencies. So it is very important for us to use robotic systems to assist human. StarLab stands for Space Technology for Autonomous and Robotic Systems Lab. We are a team of academic scholars, roboticists, and computer scientists who share the same vision to develop AI robotics for space. StarLab was originated over 10 years ago within the Surrey Space Centre at the University of Surrey in the United Kingdom. We believe AI and robotics are the important technologies for the long-term development of space technology and space missions. At the StarLab, we have expertise in orbital robotics in terms of 3D perception and navigation. This is extremely important technology to enable applications such as satellite servicing or assembly of large space telescope.
In this orbital testbeds, we're using visual grasping of targets on orbit, where we're investigating how a robot could be autonomously grasp a satellite or a part of a space debris from visual input. And we're also using robotic grippers, hands.
Shadow Robots is a robotics technology development company. Shadow Robot hands are one of the most advanced robotic hands that are currently available in the market. StarLab is offering us the opportunity to use their mock-up environments and also the research facilities to test our robotic hands in various space scenarios.
The collaboration with Shadow Robotics will really enable grasping and manipulation orbits with arbitrary objects in terms of varying size, mass, and shape. And this really enlarges the capability of the end-to-end system that we are trying to demonstrate. Planetary robotics play a significant role in terms of exploration and close examination of extraterrestrial bodies. Our technologies in planetary robotics has been primarily focusing on next generation of mobility system.
The rover here is named Marcel for Mobile Active Rover Chassis for enhanced locomotion. The chassis of this rover has internal actuation that allows a locomotion that is halfway between leg locomotion and wheel locomotion, so it can actually crawl.
I am from GMV. GMV are a multinational technology company. Currently we have an active proposal we're working with StarLab on, which is using next generation autonomy, chassis techniques for small robotic systems to enter underground terrains and challenging environments on the lunar surface.
There are also technology we developed to enable subsurface mobility, such as the drill system that we developed inspired by the wood wasp.
This drilling system is combining both main motion, the reciprocation motion and also the vibration motion together. We are also working on developing the different kind of drill bit, like convex, concave, with different cross-section contours.
The dual reciprocating drill could be used for drilling into planetary regoliths, such as on the Moon and on Mars. We want to create an actual system that will be small, will be lightweight, and will attach to one of our planetary rovers to actually test it in the field.
StarLab is very active in knowledge and technology transfer into other sectors that also deal with extreme environment, such as nuclear, oil and gas, and agriculture. The machine vision technique we developed based on deep learning allows us to very effectively detect anomalies through images.
We would like to develop an spectral robot. The robot usually will go around the plant, detect if there's any gas leakage or abnormal situation. To do so, he used the laser rangefinder and the RGBD camera to build a 3D reconstruction of the environment. And we use the thermal camera to detect any change in the normal operation situation.
I work at RACE, which is a lab specialising in robotics for hazardous environments. It's also part of the UK Atomic Energy Authority. I'm also working here at the University of Surrey in the STAR Lab. So the work I'm doing is making use of a technique called generative adversarial networks, which are a type of deep learning technique. We're looking at components in nuclear reactors. By comparing the model of what's normal with actually what's measured in the environment, you can detect things which are anomalous.
STAR Lab has a very open policy when it comes to collaboration, so we are opening these facilities to collaborators worldwide so that we can help each other to push the boundaries of the state of our technology in artificial intelligence and robotics.